morning, everyone. My name is Stefano. I'm with Conavi Medical. To give you an overview of our company, so we're a commercial stage medical device company. We develop technologies that are used to image the heart during procedures. When people think of heart procedures, they typically think of open heart surgery. That's becoming way less common. It's being replaced by procedures where essentially you insert wires into blood vessels in the leg, the wrist, the shoulder, et cetera, advance those to the heart. And what we do is we provide the imaging to support those procedures. We have two products. We've gone through the FDA, gone through Health Canada. We're doing business right now in Japan and China. We were founded in 2007 by a team of physicians and scientists at Sunnybrook, and we've been supported by about $50 million US investment to date. Very large patent portfolio. We're arguably the most active and advanced company in imaging globally. We're up to about 84 people, including 34 in manufacturing and 28 in R&D. Vast majority of those staff have engineering or biomedical physics backgrounds. 20,000 square foot facility in Toronto, near 401 in Leslie, ISO certified, and we pretty much do all of our manufacturing in-house. Just talk a little bit about our products. Our products essentially consist of two components. There's the console, which goes into the operating room. That is what acquires and displays the images and shows it to the physician. And then there's also these catheters, these wires that are actually inserted into the heart. So we've developed two to date. One is an ultrasound and optical imaging probe that goes into the arteries in your heart. Another one is a 3D ultrasound probe that actually goes into the chambers of the heart. So these are extremely miniaturized. You can see the one on the top left combines ultrasound and optics within 1 millimeter sort of a footprint. That image you're seeing right there is actually an optical lens embedded within an ultrasound transducer. And then the 3D ultrasound imaging probe is also an ultrasound transducer that has the ability to tilt based on, it's essentially on a torque cable, and depending on how fast the torque cable is spinning, that determines sort of the direction it's tilting, which allows us to render a three-dimensional image. So these catheters, there is a significant amount of sort of complexity and sophistication within a relatively small space. So just to talk about what we're looking for from a collaboration standpoint, it's really around opportunities related to microassembly. So the first is the actual assembly itself, which to date is done predominantly manually. So we're looking for opportunities for automation, whether it is assembling the imaging cores, the ultrasound transducers, the optical inserts, the application of curing of epoxies, incoming inspection of components, because a number of these components are miniaturized, micro-precision welding, and then additive manufacturing for non-planar surfaces or components. And it's also the testing of components once they have been assembled. Obviously, as a medical device company, we're subject to some pretty stringent quality controls. Also, the development of assembly, testing, jigs, and systems, development of validation assemblies with a high degree of traceability, and lastly, our catheter sheet extrusion, which currently is done pretty manually. So if anyone's interested in chatting, here's my contact information. I have the booth way over there on the far left. Happy to show people, actually I brought the catheters here today. One last thing I would like to point out with regards to the medical device industry, we're talking about benefits to Canada. Most people aren't aware that right now in Canada we have a $5 billion trade deficit in medical devices, which amounts to about 1/6 of Canada's annual trade deficit. So medical device makes up about 1/6 of that. Just want to make people aware. Anyways, thank you for the opportunity to present today.